A term you're going to hear is the NPSH, which is the acronym for Net Positive Suction Pressure. We'll briefly cover what this means. There are two letters at the end of the acronym, the NPSHR and the NPSHA. The R is the required NPSH. Each pump is tested for this value, and this can be obtained from the pump manufacturer via the pump's operating chart. Don't worry about this confusing looking chart at this point. We're going to break it down and cover that in detail in a dedicated video. Links to that in the video description down below. The R value is basically a warning or danger point. As the water enters the pump and flows into the impeller's eye, it experiences a loss of energy due to the friction. This will give us a pressure drop. At certain conditions, the water flowing through this section can reach boiling point. When this occurs, we refer to this as cavitation. We're going to see more on that in just a moment. The other letter was the A, and this is the NPSH available. This depends on the installation of the pump and needs to be calculated. It considers things such as installation type and elevation, liquid temperature, liquid boiling point, etc. The available pressure should always be higher than the required value. For example, if we have an installation and we calculate the NPSHA as 11, but the pump requires an NPSHR of 4, then the pump should be okay. However, if we installed a pump that required an NPSHR of 13, then the available NPSH is insufficient and cavitation will occur. So what is cavitation? As we know, water can turn from a liquid state into steam or a gas state. We know that water boils at around 100 degrees Celsius, and that's because it's at sea level, which has an atmospheric pressure of 101.325 kPa. But if we went to the top of Mount Everest, then water boils here at just 71 degrees Celsius, and that's because the atmospheric pressure has reduced to 34 kPa. As the atmospheric pressure reduces, it becomes easier for the water to boil. So at the suction inlet of the pump, we know that there is going to be a pressure drop. And if this pressure is less than the vapor pressure of the liquid being pumped, then the water can reach boiling point. When this happens, cavitation occurs. During cavitation, air particles within the water will expand as they reach boiling point. These will then collapse in on themselves very rapidly. As they collapse, they will damage the impeller as well as the pump casing. This removes small parts of metal from the surface, and if this keeps occurring, then it will eventually destroy the pump. Therefore, we must ensure the available pressure is higher than the required pressure of the pump.